Bismillah ar-Rahman ar-Rahim. This is the student Alkhalil Abdul Hamid Saif Ahmed with the ID FB2000 and then 2. Today I'm presenting 5 questions which are question number 5, question number 1, question number 6, question number 11, question number 16, and question number 21. In question number 1, we have a circuit and we have to do mesh analyzing, and then we have to do the equation of nodal analyzing, and then using the way of source transformation. We go to multigen. We see that we have the same answer as we solved the circuit. We have here question number 2, which is number 6 actually, which asks us to have the source transformation and then using mesh analyzing to solve for voltage and current. When we go to multigen, we see that we have the same answer as we did. In question number 11, this is actually AC, and we have to do like Thevenin, and with Thevenin we have to find the Z Thevenin, and then from Z Thevenin we have voltage Thevenin, and then we have to use the impedance and voltage divider. We go to question number 16. Actually, in question number 16, we have 4 points here, A, B, C, D, and we have to use nodal analyzing to solve this circuit. After that, we have 4 equations. The 4 equations are here, and with using from equation number 3, we have VB equals to 13 VC minus 4 VB. And from equation number 3, we put it in equation number 1 and 2, and then we got the voltage in all the points, VA, VB, VC, and VD. When we go to multigen to see it, question number 16, we have the same answer as we did. Going to the last question, question 21. Actually, in 21, we have to do superposition in the circuit. First, we did the superposition here, and we deleted the voltage 25, and then we had 7,000 with 120 ohm by parallel, and then we put it again, and we closed the another voltage there, and we had also 6,000 with 5,000 also parallel, and then we got the answer. Also here in multigen, question number 21, we have the same answer as our solving. That was the 5 questions, and thank you so much.
Assalamualaikum, and my name is Muhammad Zani Bihanim. My meeting number is FP2034. Representing the question 2, 7, 12, and 17. BFM 1343, Fundamental of Electrical Engineering. So I'm presenting the question 2, which is this is the circuit, and this is the equation that I can conclude in this circuit, I'm using the mesh theorem, which is the first current that I can produce is 2.43 ampere, same as the simulation. They are using multism simulation. The second one is negative 76.9 microampere. The third one is negative 2.1 ampere. The fourth one is 950.12 milliampere. So the value at voltage, which is the first one is 24.3 volt. The second one is 135 volt. The third one is negative 7.68 volt. The fourth one is 20.54 volt. The fifth one is negative 0.028 volt. Last one is 48.45 volt. So the power that I have calculated in this circuit, which is the first one is 312.5 watt. Third one is 0.59 watt. Fourth one is 21.1 watt. Fifth one is 1.2 times exponent of negative 5 watt. And last one is 46 watt. We move on to the question 7. Question 7 that the question need is by using the galvanometer, which is this is the Thevenin A and B. So the VA is 23.45 volt, and the voltage division in the VB is 23.64 volt. So the Thevenin voltage, which is VA minus VB, which is I can get is 0.919 volt. So this is the R Thevenin, which is I can conclude 471 volt, 471 ohm, and the resistance in auto equilibrium circuit, which is the same, but the current is negative 0.4 milliampere. So the current at galvanometer, which is negative 0.374 microampere, actually is microampere. In question 7, same as the simulation that I have made used by using the multism. So the question 12, I forgot to include the power to by 5 kilo ohm and 20 kilo ohm, which because my multism is have the evaluation date have ended, so I forgot to put the power, but the value of VA, VB, and VC, which is the same, which 2 volt, 12 volt, and negative 8 volt, and I made a careless mistake, which is negative 12 minus 10, which is actually 2 volt, but I have made 12 volt. I don't know why, but the calculation I've made the simulation before, but it's actually conclude the same answer in the same answer as I calculate in this slide, which is power to the 5 kilo ohm is 20 milliwatt, and the power to by 20 kilo ohm is 3.2 milliwatt. And the last one is by using the superposition theorem, the by using simulation is 4.5 ampere, and by using the first one is same as the while 5 ampere is acting alone, which is same as the simulation that I made up in the multism, which is 4.09 ampere, and the second one is 4.41 4.1 ampere. 0.41 ampere, sorry. Which is same as the simulation for 411 milliampere. The third one is negative 0.49 milliampere, which is I can get 491 microampere, which is same as the number the answer that I calculate. And the last one is the total current of this question is 4.4995 ampere. I think that's all for me. Thank you.
The circuit for Q3 is, question 3 is this. I get this. The value we get from the circuit. The calculation for the question 3 is we replace by short circuit here. 100 multiply 25 over 125, we get 25 ohm. For the Thevenin theorem of Thevenin's resistance, we get 126.25 ohm. For the Thevenin voltage here, KCL at V minus 35 over 100 plus V minus 0 over 25 plus V minus 25 over 19 plus 90 plus 30 equals 0. V minus 35 plus 4V over 100 plus V minus 25 over 120 equal to 0. In the last one, we got V 4.33 volt. Next, we find I. I is current for this for the circuit. We find I current. We got negative 26.67 over 119. We get negative 0.109 ampere. For the Thevenin theorem, we get negative 19I. We replace this. We get answer from this. We put here and we get negative 9.79 volt. For the load current using Thevenin's theorem, this is I load. We use the formula VTH over RTH plus R load. For the I load for 8 ohm, we get 72.93 milliampere. For the 38 ohm, we get 59.6 milliampere. And the last one, 59 ohm, we get 52.85 milliampere. Newton theorem. What is Newton theorem? Newton theorem is same as Thevenin's resistance, like that. We use mesh analysis to solve this problem. For the first equation, 25I1 negative 5I2 equal to 0. For the second equation, I1 minus 9.8 I2 plus 3.6 I3 equal to 1. For the third equation, 16 I3 minus 9 I2 equal to 0. From this equation, we want to solve to get I1, I2, I3. We get I1 299.02 milliampere. For the I2, 95.08 milliampere. Last one, I3, 53.48 milliampere. For the in I load, I3 is 53.48 milliampere. For the Norton's equivalent circuit, this is the formula IR load. We get for the 8 ohm 15.29 milliampere. IR load for 38 ohm is 41.107 milliampere, and the last one for the 59 ohm we get 36.445 milliampere. Okay, we go to the question 8. This is question 8. Using mesh analysis, find VA, VB, VC, VD, VE, VF. This is the circuit for question 8. The calculation for question 8 is I1 214I minus 40I2 equal to 6. For the I2, negative 40I plus 1310 I2 minus 300 I3 equal to 4. I3, negative 300 I2 plus 500 I3 equal to 3. We using Cramer's rule for this circuit. I1 for the I1 from the we use this 1, 2, 3. We get 1, 2, 3 Cramer's rule. We get for the I1 31.182 milliampere. For the I2 37.091 milliampere. For the I3 28.255 milliampere. From the what we get from I1, I2, I3, we use to get volt, to get VA, VB, VC, VE, VD, VE, VF. Oh, I forgot to put here. VA, I find 16 volt. VB 2.3636 volt. VC 26. Sorry, VC VF VC negative 13.491 volt. VF negative 39.999 volt or negative 40 volt. For the VE, for the VD negative 70.001 volt. Okay, we go to the question 13. This is the question 13. The circuit for the question 13, I get this for question 13. The calculation for question 13 is we transform this capacitor and the inductor first to find Zin. And the last one, we for this circuit we use parallel equivalent. We cannot solve this circuit. We cannot use the normal solving. And the last one, we get Zin 31.044 and 3.508 degree. For the question 18, find VA using superposition theorem. Okay, first we look at the circuit first. This is what I get volt from result from the question 18. The calculation for question 18, we use to find VA here, VA. This second, we have two cases. Case 1, consider only 25 voltage source. We use 25 voltage here only. For VA1, we get 20.57 volt. For the case 2, consider only 10 volt voltage source. This we use 10 volt, but we not use 25 volt like here. We not use. For the last one, we get VA2 1.02. According to superposition theorem, VA equal to VA1 plus VA2. VA1 plus VA2, we get 20.57 plus 1.02 equal to 21.59 volt. Like I get from the circuit. 21.59 volt. Thank you. This is that's all
Hello,
from me.
it's Mama Hafiz Benwa. My meeting number is FB20035, and I will answer in question 5, 10, 15, and 20. So for question 5, using superposition theorem, find voltage and current. So this is for 25 voltage. We calculate this, and using superposition theorem, so this formula and substitute and get V1 4.261. So we substitute this use because we want to as to want to nilai current value, so we get a 0.0195. So for volt we substitute also and times the ohm 950 and get the volt. So for current 1.5 we also use superposition theorem, so we calculate this and get the currents 0.1544 ampere. So for 3.5 for 3.5, this is the current, and we use this substitute and we get the equation 1 and equation 2. So we using simultaneous and we get a negative 0.387. So the total current, we plus the total current and total voltage and get the value. So current through 950 ohm. So we use the current this times by 950 ohm and get the answer. And this is the multisim. Okay, next for the question 10. Okay, for the question 10, VA equal to 35 cos 10t plus 15. So find IS. So we use a captive need the formula, captive reactance and inductive reactance. J equal to, let me see, and negative J equal to 10 times 107, and we get this. And this inductive reactance, we use this capacitor, inductor, and get J. So we calculate and get this answer. So we using mesh analysis on loop 2. Loop 2 using mesh analysis, and we calculate this and get the IS 2.315. So this is the answer. This is the multisim. So next is question 15. So question 15, IS equal to 35 cos 10t plus 15. So find IA. So we have a formula same like question 10, capacity reactance and inductor. So we calculate the capacitor. 1 equal to j times 10 times 0.7 and get negative j per 7. So electric reactance j times 108 times 10 and get 8j. So for the new circuit, using nodal analysis, and we calculate get 25 and 50 theta. So this same, this is for capacitor and inductor. So we calculate this 24.15 times 6.47j equal to divide by 0.0691 equal to 0.1243j. So we calculate plus and get the answer. So IA, but we find the IA, so IA V equal to 15 minus J per 7 equal to 2.711 plus 11.39J. So we get the answer. So the IA is this. The answer is IA. So this is a multisim 3.0 ampere. So for the last one is question 20. Determine the total impedance. So formula total impedance Z total equal to 2000 plus bracket Z1 linear to Z2. So Z1 linear to Z2. Okay, we get substitute formula 1200 minus negative J 17 and 220 plus J 11 divided by 1200 minus J 17 plus 220 plus 711. So we calculate and get the answer 186.16. So Z total, we substitute this equation 0 plus the answer. So we calculate and get 2186.022. So we find the current I. So I V in divided by Z total. So in this 120 tan theta and divided by the answer. So we get this. So this is the multisim in the graph. I cannot use the multisim because the evaluation time with 7 days I finish. I cannot use, so I asked to my friend to print screen this, so I simulate and get the graph. Okay, thanks. This all for me.
Hello and Assalamualaikum. My name is Muhammad Asbi. ID number FP 20089, and I'm gonna present the question for 9, 14 and 19. This one is the simulation for question 4. So the question 4, we need to find VTH, Z and ZTH at point A and B. The first one we need to do is short circuit the voltage source, and then plus the resistor here, we got 10.2, and this one go parallel with 2.7 kilo ohm, and we got 2.13 kilo ohm here. And then the way to get the ZTH is just plus the resistor here, and we get the ZTH. The next step is you use nodal analysis here. Just calculate using nodal analysis, and we get the answer for VTH 25.11, and here the final answer. So for the next question is question 9. This is the circuit, and by using analysis we need to find IO and VA here. So the first step is to find the equation for loop 1, which is 50 volt equal to 440 ohm, I1 minus 20 I2 minus 400 I3, and then we go for I2 here, and we got this, and I3 loop 3 here, and we get the equation. So from this equation we can use the Cramer's rule to find out what is the IO here. So this is the step I use for Cramer's rule, and this is for delta, this is delta 1, this is delta 2, and this is delta 3. So to get the I1, we need to delta 1 over delta, and we get 15 per 46 over 46, and the I2 is equal to, is same as I1. So I3 quite different, is delta 3 over delta, and we get 0.217. Because of IO equal to I3, so this is IO. So to get the VA to the answer, we just need to take the resistor R6 and time with IO, and we get 46.8, and this is the result for the simulation, which is a little bit different at voltage. And this one is question 14. We need to find voltage for VA, VB, and VC, and current through each resistor based on the analysis. So this is the result for the simulation here. The VA, VB, VC, and current through all of each resistor here. So the calculation here is, first we apply KCL for VA, and we get VA equal to negative 1000 volt, and then we go to VB, we apply KCL2 for VB, which is IB I plus I3 plus I4. So solve the equation, and we get VB equal to 320 volt, and VC, which is we know that this is 200 volt and is equal to 200 volt. This one is the superposition theorem to find the VA here. So the first thing we should do is open circuit for the current here in the simulation. I already opened it, and this is parallel, so we got 15.56, and to get the VA1 is we just use voltage divider rule, and we got this, and this is the VA1. So for the 3A source here, we just open circuit here and close for the voltage, and just calculate it to the current, and we got negative 40.4, is quite similar to the simulation. I'm sorry. this is the result here. And for the final VA2, and then we go for VA3. This is so for VA3 here, you open circuit and this close. So just use KCL here. Your equation 1 and equation 2 for loop 1 and loop 2, and then solve these two equation. We got I equal to 0.85 and I1 equal to negative 0.96. So for VA, just key in the answer here and we got 19 volt, which is, and this is the result for the simulation, 19 volt. And last one we just plus A1, VA1, VA2 and VA3. And the result is and this is the result here.